Okay, welcome, Chanel and Joy. Let me tell you the plan of the day. Today actually is one of the lighter days for our class because we don't have midterm. The midterm's over. So what we're going to be doing today is we're going to be working on chi-squared tests. And what that is all about is something that we haven't done yet, and that's dealing with qualitative survey data, and especially qualitative where it's not the yes-no question. So we haven't been able to analyze that. We haven't done that at all. We've been dealing with quantitative and the yes-no pretty much for the last month, right? I don't know if you realize that, but that's what we've been doing throughout. But there's lots and lots of studies or survey questions where it is a qualitative. Things like ethnicity, what is your ethnicity? Or maybe it is what's your profession? Again, that's not a number. You wouldn't have a number answer on that. And there's a lot, again, I can go on and on and on, and there's lots and lots of examples of it. We're going to be doing 3 types with the qualitative studies. And by the way, even though it feels quantitative, sometimes it's still qualitative. So if you're doing age, that sounds quantitative, but sometimes you want to look at age brackets or generations. So maybe children, millennials, right? Maybe Gen Xers, and then seniors, something like that. And even though we're asking how old you are, we're putting them into some kind of bracket. Any questions on that idea? So that's the plan of the day. I want to also mention there is something coming up pretty soon, not tomorrow or anything, but hopefully you're starting to work on it. And what's the next big thing? Yeah, Project 2. So you definitely want to get Project 2 started. And what I recommend, and some of you have done it already, is to go ahead and post your Project 2 idea in the Project 2 discussion forum. So I've noticed, in fact, let me see. Let's take, oh, there we go. There's already about 3 or 4 that have already talked about what they're doing. And it's really important because, like, for example, one of them didn't work. So if you don't post in the Project 2 discussion forum, then you're on your own. And if it doesn't work, you're pretty much screwed because you'll have done all this work and then you'll find out it doesn't work for Project 2. So what you should do is you should post your null and alternative hypotheses and maybe how you're going to collect your data. Again, you don't have to do a survey. You can collect your data online or whatever, as long as the data that you collect you can't find a census. You can't do a census, as long as it's just data, a sample of something. Okay, so again, any questions about Project 2? Okay, just doing your outline now, which is good. Yeah, so, and as I mentioned, it's due in, I think it's next Sunday it's due, if I remember right. So don't wait until Saturday to start writing it. Okay, I would write it early so that you can send me a draft, and then I'll look at your draft, I'll give you lots of feedback, and that should help you. If you try and do it without sending me a draft, good luck. It's much, much harder because you won't know what I'm expecting. And I don't want it to be a surprise. And also feel free to post on the Project 2 discussion board any questions you have about it. I know there's some people that are still looking for partners. Okay. Any questions at all? Okay. Today is a lighter day. It might be shorter. We've been going kind of long lately, so this could be a shorter one. We'll see how it goes. And again, we're going to do chi-squared. I thought I would look at an article. One of the things about chi-squared, it's not something you'll ever see in just news, for example. You won't see them ever mention chi-squared, or even like Gallup poll. They won't talk about chi-squared. It's too difficult. The place you're going to see chi-squared are journal articles. And that's pretty much it. But given that this is a college class, And one of the main purposes of this class is to get you ready for upper division coursework in whatever major you're in. In upper division coursework, you're going to have to read about studies that were done and they were posted into some journal article. They tend to be hard to read because you kind of have to be an expert in the subject. So one of the things about journal articles, I'm not sure if you know how they work, but what's the main difference between a journal and a news, okay, or just a written publication? It's factual. Well, that could be a news too. News isn't always fake. No? Okay, the main difference is it's peer-reviewed. It's peer-reviewed. What that means is there are experts in the subject that read through and make sure that it's right. And one of the things they do is they make sure they have done the statistics properly so that they can back up what they're saying. And in almost every journal article, there's going to be statistics to back up what they're trying to show is true. Okay, and I personally have been a peer reviewer. Okay, my expertise, any guess? Okay, but something very special about it, not just statistics. Okay, online teaching. Online teaching. Okay, you might have guessed that since this is an online class, but I'm one of the national or statewide online teacher people or reviewers. So I've done some of that. I'm also a specialist in open educational resources, the fact that everything is free in this class. Okay, that's the other thing that I'm kind of, that's my specialty. And I've been a peer reviewer in journal articles that involve those two things. Okay, we all have our expertise. I'm in a community college, so I'm not the math specialist anymore. Okay, that would be more university professors. But online teaching is definitely, I'm one of the main people. Okay, so that's another thing is the audience in a journal article. It's assumed that they're all educated. Okay, uneducated people tend not to read journal articles. Okay, it's not for them. They won't understand it. Okay, and usually they're very educated. So they're professors or graduate students or at least upper division students. So what that means is that you can assume that they know statistics because every very educated person knows statistics. It's just part of a being. And unfortunately, not our politicians, not all of our politicians are educated in that way, and they don't all know and understand statistics. But if they did, maybe they'd make better decisions. Okay, that's my little political statement. But I can say that statistics should be a requirement for being a politician. So I want to share a journal article. I want to share the one that I posted because it has a couple things that, again, I posted it, but I didn't answer all the stuff, and I want to show you a few things. I want to show you what they look like and why they do what they're doing. So let me go ahead and share my screen. And I really like this one because it was very appropriate for a Tahoe thing, because it's difference in sensation seeking between alpine skiers, snowboarders, and ski tourers. Okay, and that's what, at least in the wintertime, that's what we're all about in Tahoe. We're all about skiing and snowboarding and touring on skis. Okay, and especially this winter because we have so much snow. So I want to just show you a few things, just show you what a journal article looks like. First thing, it's very high level. I'm not going to, read through every word here, but it is very high level. I wonder if I can make this bigger font. No, that didn't work. Okay, the chat. There we go. Let's see. You can't see the article, Tammy? Chanel and Joy, can you see the article? Because it shows that you're seeing it. Okay, it might be just you, Tammy. Yeah, I'm not sure. That's a hard one to fix because It's just you, the rest can see it. So I'll read some of it. So you'll notice that it says, for snowboarders in comparison to alpine skiers and ski tours, H of 2 equals 41.5. P is less than 0.001. So hopefully, when you see P is less than 0.001, what is that referring to? Yeah, that's the p-value. Okay, the H of 2 is 41.5 is the test statistic. That particular one is one that we haven't covered in this class. There are a lot of statistics we don't do, but there's some that we do. Okay, something I like about this is that in the statistical analysis section, what are the first 3 words? Or 2.5 if you count a hyphen as breaking it up. Okay, do y'all see them? Yeah, it says chi-square tests were used to compare alpine skiers, snowboarders, and ski tourers regarding age categories, sex, skill level, risk-taking, and accidents. Okay, so this is what it looks like when you see a chi-square test. So you'll notice that for sex, let me start out with that one. They are comparing females to males on whether they are engaged in alpine skiing, snowboarding, or ski touring. And what they're looking at is they're saying, is there a difference based on gender in the distribution of ski type? Okay? There's no good word for that, but skiing, snowboarding type. Any questions on that? Okay, so this, when you're comparing the distribution of 2 different populations, in this case, it's the population of females and the population of males. And the survey question here is, what kind of snow play do you do? Alpine skiing, snowboarding, and ski touring. And you'll notice that this particular survey question is qualitative, right? So Chanel, you're in Tahoe. What kind of snow play do you like to do the most? Snowboarding, okay? Notice she didn't answer 15. She gave a word. And when it's a word answer like that, it wasn't yes, no either, then that's qualitative. So then we're going to be in the realm of chapter 11. Any questions on that? Okay, then they do some more. They say chi-squared 2 equals 0.67. Okay, first thing, this is not an X, it's a Greek capital letter chi, C-H-I. Okay, or this curvy looking X thing is really how you spell it. Okay, one of the things about the square, you don't have to know the deep math about it, but what the square tells you is that you only get positive values, which means that you only have to deal with right tail tests. There is no left side. Any questions on that? So the test statistic is 0.67. Okay, just like we've had a test statistic for a Z statistic or a T statistic, now we have a chi-square statistic. Okay, now comes an interesting thing. Again, it's nice that we get to see a real journal article and you can see what it is. No, it's definitely not a t-test. It's a chi-square test. And this is a chi-square test for homogeneity. Okay, so that's a really good question, Chanel, because t-test is what we did in different chapters, right? We did that in chapter 9. Now we're in chi-square test. In this case, it's a chi-square test for homogeneity. Anyone know what the word homogeneity means? It's an English word, not a math word. Any of you know that word? Yeah, it means everything's the same, exactly. And you know the prefix homo, right? So, for example, homogeneous means that the milk has been mixed in, so it's all the same. Homosexual means that you like the same sex, right? Homo sapien means same as us. Okay, so that's what homo is, right? So in this case, homogeneous, homogeneity is what we call the test. Okay, it doesn't have to be same sample size, actually. The question is, we're testing to find out if the distribution for females is the same as the distribution for males. Okay, that's what H naught is that the distribution for females is the same as the distribution for males, and H1 is the distribution of snow play is the same as the distribution, is the same for females and males. It's, sorry, different for females and males is H1. Any guess? Yeah. So let me emphasize something, Tammy. It's always asking about the distribution, and on your final exam, if you have to do a test for homogeneity and you don't have the word distributions in it, then I will take off points. So when we're doing the H0 and H1, we use words, not symbols. In chapter 9 and 10, we only use symbols. Keep that straight so you don't lose points. Any guess on what NS is? Again, this is a journal article. N period, S period. Any guess? Not seeing y'all jump in at once, so maybe I should tell you. Yeah, not statistically close. It's really not significant, but you get the right idea, Tammy. So it's not significant. Okay? So what, again, in a journal article, that's enough. Everyone knows what that means. You don't have to say anything else. Okay? I'm going to look at accidents, because accidents is very different. Here, we've got 2 survey questions. We're not comparing 2 populations. We have 2 survey questions. Does that make sense? One survey question is how many accidents have you had? Never one or more. I know that sounds quantitative, but the way it's written, it's not. It's qualitative. And then the other survey question is, what is your favorite snow play? When you are comparing, when you want to find out if the answer to one survey question is a predictor of helps you predict the answer to another one, we use a chi-squared test for independence. Any questions on that? Okay, and here we go. We have chi-squared of 2. 2 means degrees of freedom. Okay, and we'll get into that on the next test. Is 18, and the main thing is the p-value. P is less than 0.001. If p is less than 0.001, I'm hoping you all know what that means now. What you get when that happens. Yeah, so it's statistically significant. So that means that we have statistically significant evidence to support the claim that the number of accidents people have been into in snow play and the type of snow play they like to do are dependent. So just to let you know, when you're doing your H0, you need to have the word independent. And when you're doing H1, you need to have the word dependent when you're doing a test for independence. So those are some words that I require. Any questions on this? Any questions? Okay. I was actually kind of surprised. Okay. I was kind of surprised that what I was surprised on was that the gender and the type, the age and the type of snow play were, they weren't able to find statistically significant evidence on that either. Okay, and that's surprising because I thought young people like snowboarding, but I was wrong on that. Yeah, so I thought old people skied and young people did snowboarding, but I was wrong. Okay, it used to be that way. Any questions at all on kind of the idea of these two chi-square tests?
I'm not sure, Professor, that it's not still that way. It's just under 34 is still young. Go up to my generation. I'm 52, and my husband is a skier and didn't snowboard till his late 30s. So I just
That's
think
true.
they're still pretty young.
That's true. And obviously, personally, I snowboarded before the word snowboarded existed.
Sure, he was born and raised in Tahoe, and so
I had to make my own board because you couldn't buy them. Yeah, I was in Southern California mountains when I lived there. But anyway, this is what it is. At least it's statistically insignificant. It doesn't mean that there isn't a difference. It just means that it's not statistically significant. Okay, any questions at all on this example? Any questions? Okay, so there's a third type. So we've gone through two. One type was test for homogeneity, and that's when you have two populations that you don't know their distributions for some qualitative question, and you want to compare them. Then there's a test for independence, and that's where you have a population, you have two qualitative survey questions, and you want to find out if they're independent or dependent. Then there's a third type. And the third type is when you know a population and you want to find out if some other group has the same distribution of the known distributions population, okay, or some known distribution. So what I want to do, and let me do this as I talk, because I can pop this in. Almost there, and then I'll share my desktop so you can see the article for a little bit more, in case you have questions on it. There we go. So now let me reshare my desktop, and now we're going to do one of the other type, and we're going to use our calculator. So let me go, share. Okay. So here's the question. Is traffic equally bad in the north, south, east, and west shore? So if you don't know Tahoe well, we usually break it up into 4 parts, north, south, east, and west. And what they've done, okay, or fictitiously done, is a count of 600 randomly selected cars in the Tahoe Basin, found 170 in the North Shore, 212 in the South Shore, 110 in the East Shore, and 108 in the West Shore. Conduct the appropriate test and provide your interpretations. Okay, so the first thing, when you're jotting the data down, because it's not really a survey question, now it's jotting data down, what are you going to be writing down? What words are you going to put down when you're jotting data down for this example? Data. Okay. Not quite car counts. Still waiting. The hint is they're going to be words. You're going to, yeah, there we go. South, north, east, or west. You're going to look at that car and you're going to say, where is it? And you're going to jot down, found it in the north. Does that make sense? This is a qualitative study. So that's the first thing. Notice that we only have one population, right? It's the population of Tahoe cars. Okay, so we have one population. And then not only do we have one population, there's just one survey question. Where was that car found? And that'll be south, north, east, or west. Any questions on that so far? Okay, then you got to focus on the first few words of the question. Okay, is the traffic equally bad? If it's equally bad, then what should you see in terms of number of cars? Yeah, equal, the same number of cars, exactly the same number of cars in each of the 4 areas. Now, we have a word for that. And in fact, we had a whole chapter where that's pretty much all we did. You don't know what that is? If everything is the same, we had a word for it, special word. Remember? It's been a while. Okay, the word's not blank, but I think it made your, here's a hint, chapter 5. Does that help? Proportion, that's not what we did in chapter 5. Remember? Uniform. Do you remember that word? Yeah, uniform meant everything was the same. So now that I have come up with all the things I need, we can write down our null and alternative hypotheses. So H dot. And that is the distribution of cars is uniform. And H1 is the distribution of cars is not uniform. Any questions on this? Notice the keyword distribution, that needs to be there. Because that's what we're doing. We're testing about a distribution to find out if it's a distribution. Yeah, that's a good question, Chanel. No numbers. Remember, we're doing qualitative. Yeah, so in chapter 11, everything is qualitative. So one thing's no numbers and no symbols either. Other than H0 and H1, we do sentences. So just to note, we do sentences for chapter 11. For chapters 9 and 10, no words allowed in H0 and H1, only symbols. I will take off points if you give me words in chapter 9 and 10. Okay, now let's write down the test we're going to use. The test we use is called the goodness of fit test. Gotta click on that and that and that. And I usually ask you to write down the name of the test. This is the goodness of fit. Sometimes it's called the chi-squared goodness of fit. But everything we do in this chapter will be chi-squared. Any questions so far? Okay, so the next thing we need to do is we need to make a little table. And we're going to make a table on what's called the observed and the expected. Oops, one more try. Good. So we often use O for observed. And the observeds, those are easy. They were 170. They were 212. 110. And 108. Then we have the expected. The way the expected works is we say, well, if H0 is true, what would we expect? So if it was uniform and we looked at 600 cars, then we would expect it to be equal, all of them to be equal. So to find out how many of each you'd expect, you take 600 and divide by 4. Any questions on that idea? And 600 divided by 4 is 150. So the expected will be 150, 150, 150, and 150, because we'd expect them all to be the same. Is that clear? Okay, let me write this down so I don't lose it. 170, 212, 110, 108, because I need my calculator. 150 so I can remember. Now I'm ready for my calculator. So, Chanel, Joy, and Tammy, do you have your calculator with you? Yes, yes, Joy? Hopefully, I'm not sure if you can type, but okay. So follow along because it may not work for you. That's the bad news. Okay, so I'm going to share my desktop again with the calculator. Let's clear what we had last time. And what I'm going to do, first I'm going to get a stat. This will work for everybody. I'm going to edit. I'm going to clear out L2 and clear out L1. You should know how to do that at this point. For L1, I'm going to type in my observed, which was 170 and 212, and then 110 and 108. For L2, I'm going to type out my expected, which were 150. Oops, let's try again. 150, 150, 150, and 150. Any questions so far? Okay, that should work for everyone. Now comes the tough part. I am going to hit stat again and go to tests. Now cross your fingers and I hope it works. I hit the up arrow and I see chi-square GOF tests. Tammy, Chanel, Joy, do you see that? Okay, Chanel, if you're in Tahoe, if you can get to my office, that'd be the best because I could put it in your calculator. Otherwise, you're going to have to program it. And I do have a video on how to program it, but it's a pain. Tammy, you're in good shape. And Joy, you're being quiet, so I don't know. Okay. So if you don't have it, you're going to have to download it or program it in. So I hit enter. The observed is L1. The expected is L2. DF stands for degrees of freedom. And what that means is the number of categories minus 1. In this case, we had north, south, east, and west. There were 4 categories. 4 minus 1 is 3. So degrees of freedom is 3. Color is never important. Any questions before I hit calculate? And Chanel, you're going to have to do it differently, but you got to get that program into your calculator. Okay, and again, if you can find me in my office hours tomorrow, if you're around tomorrow, I could do it for you. Because what I do is I take my calculator and I pop this guy into it, this one in mine, this one in yours, and then I put it in. That's the easiest way. Okay, and Joy, if I remember right, you're not from Tahoe either, are you? Yeah, because I know, Chanel, at least you're in town, so you might have a chance. I don't know how long you're staying here. So there is a video, maybe I'll show that in a bit, on how to program into calculator, how to make it happen. Okay, now I'm going to hit calculate. And there we go. Chi-squared is 50.72. By the way, is a p-value 5.61? Yeah, definitely not. Yeah, there's an E negative 11. It's actually 0.00000000561. So it's basically as close to zero as you'll ever see. Any questions on that? Yeah, it's very statistically significant. We have, so let's now write down the conclusion. And what we can say there is strong statistically significant evidence to support the claim that the distribution of cars in Tahoe is not uniform. Okay, so hopefully you know that whenever you can reject the null hypothesis, you just say there's statistically significant evidence to support the claim that, and then you write H1. In this case, it's already a sentence. You just copy and paste it in. I use the word strong because we had such a low p-value. Any questions?
Professor?
Yeah.
You told us how to get the degree of the 4 minus 1 is 3. I can't remember the term.
Degrees of freedom.
That's it. And but what is that? What does it mean, or is that beyond the scope of the class?
It's beyond the scope of the class. It's heavy math.
Okay, no problem. Thank you.
Yeah, I could show you and you'd probably cry. Yeah, chi-squared is brutal, by the way, if you really want to see the mathematics behind it. So
I trust you.
Yeah, a lot of what we're doing has brutal mathematics behind it, but we got the calculator, okay? And if you don't have the calculator with you, we have the computer. My spreadsheet does it all too. Okay, so the funny thing is the statistics that I took was the brutal mathematics. I never did elementary stats. I did brutal mathematics statistics at graduate level. So it was a little different. So you can trust me, it's brutal. Yeah, so you don't have to worry about it. Okay, but you do have to understand how to interpret. That's more important. Okay, any questions on this example? All right, let's do another example. And let's see what we can look at. Just a minute. Okay, by the way, as always, if you don't say anything, then you're going to lose this because I'm about to delete everything here so that I can post another one. Last chance, gone. Okay, so here we go. Is there a relationship between the day of the week a person is born and the type of smartphone they own? Okay. So the table below shows the results of a study that was recently done. Conduct the appropriate test and provide your interpretations. Okay. So, you know, if you believe in that kind of astrology kind of stuff, then maybe there is. Any questions so far? All right, so the first thing is what kind of test is this? What kind of hypothesis test are we going to do? What's the name of the test? Any thoughts? It's chi-squared, but which one? We got 3 today. What is the name of the test? Yeah, Tammy got it. It's the chi-square test for independence. That's the first thing. Any questions on that so far? Okay, so it's a chi-square test for independence. Now we need to write down what our null and alternative hypotheses are. Do you remember what word I said must be in there if you're doing a chi-square test for independence? I think you know, but you just had a weird spelling of it. Yeah, independent and dependent. Distribution is for the other two tests, Chanel. So when you're doing a homogeneity test, or if you're doing a goodness of fit, distribution's got to be there, or distributions. So H naught is birthday. I'm going to write with 2 words because the day of the week they were born in. And phone ownership. Let's go smartphone ownership are independent. What's the only difference between H naught and H1? Yeah, the independent becomes dependent. Birthday and smartphone ownership are dependent.
I would have thought H naught would have been dependent and the other way around.
Definitely not. Definitely not.
Okay. Never. Okay.
Remember that H naught is a status quo. Like, there's nothing special about this. They're all the same.
All
you
right.
see that?
Yes, I do. Thank you.
Yeah, so it's kind of like a version of equal. Whereas dependent means no, this one over here is special.
Gotcha.
If you know someone was born on Thursday, then it's probably more likely they have an Android. You see?
I do. Thank you.
Okay. Any questions so far? Okay, so the next thing to do is our calculator. So let me do a new share. Let's do our calculator. Okay, this is very different in terms of the way you do the calculation. So follow along. And this, by the way, will work on everybody's calculator. Okay, as long as you have, one of the fancy calculators, TI-83, 84, 89, Inspire, any of those that'll work. So let's clear out what we had. Here's what you do. You go second, matrix. Hit enter. Sorry, not enter yet. One more time. Second, matrix. I need to go to edit first. Go to edit, and then hit enter. Okay, our matrix had 3 rows and 7 numbers. So it's 3 by 7. Hit 3, and then you could hit enter, and then 7, and then enter. Okay, to save some time, I've already put the numbers in. Hope that's okay with you guys. So then you just type in the numbers, 75, enter, 72, enter, etc., all the numbers that we had in our table. Any questions on this? Okay, it's pretty easy if you just follow the steps. And you type in all the different numbers. And then once you're done typing those numbers, we're going to quit. So you go second, quit. Then I'm going to go to stat, tests. And again, when you're doing these last few chapters, the up arrow is faster than down arrow. And we're going to, what they say, chi-squared test. Not GOF, but just chi-squared test. Any questions so far? I hit enter. Observed you want to be A, so that's good. Expected doesn't matter, so B works just fine. Color never matters. Any questions so far? And I hit enter and calculate. Okay, so our chi-squared, our test statistic, is about 9.0596. And our p-value is 0.6978. Okay, you should all know this by now. We get a p-value of 0.6978. What does that tell you?
Not significant.
Right, it's not significant. Okay, not even close. Do y'all agree? So now we're able to write out our conclusion. So hopefully you know the first few words because it's always the same. There is statistically insignificant. And there are a few ways of writing it. I like this way. Evidence to support the claim. I like to write whether or not. That way you don't have to remember which one to pick on. And then you can pick on either because we wrote whether or not. I'm going to just pick the first one. Birthday and smartphone ownership are independent. Any questions on this? I tried to make this realistic. Okay, if you thought that the day of the week that you were born on had anything to do with the kind of smartphone you have, then you're pretty crazy. Do y'all agree? Okay, and if you know Tahoe well enough, north, south, east, and west, completely different number of cars. South has most of the cars. You don't do astrology. Yeah, they've done a lot of statistics with astrology, and they've never gotten a low p-value. Okay, it doesn't work. Any questions at all? Any questions at all in this example? Okay, so let's try another one. Again, today's a day of just doing examples. There's not a lot of theory at all in these. Have you noticed that? The hardest part is deciding what test to use. Once you know that, you just kind of proceed. So as always, let me know now if you don't want it erased, because it's being erased as we speak. Gone once, twice, gone. And this is an interesting one. We're talking about this. I may need to, you know what? I think I need to get this one a little smaller. I have to do this one more time. I just realized my font is so big that I'm not going to have room to do anything. Come on. It's not letting me. Try doing something. Uh-oh. Uh-oh. Delete and reinsert. I know, it won't let me delete and reinsert. That's the problem. All right, I think I just got to kill it. Let me go new. That's another way. And then, sorry about this. Not sure what just happened, but it was mean to me. All right, one more try. And this time, I'm going to drop the font down a bit. There we go. It's small to read, but there's a lot there, and we'll need to have stuff here. Okay, so here we go. Men and women statistics students were asked how much they agreed with moving from a calculator-based statistics class to a computer-based statistics class. Results are shown below. Conduct the appropriate test and provide your interpretations. Okay, and by the way, this is kind of real, and it's something I've been wanting to do for a while, especially for my face-to-face class, it turns out, is to go to computer-based because that's how people do statistics. But here we go. And you've seen these answers before: strongly agree, disagree, neutral, agree, and strongly agree. Do you know what that's called? It's actually a psychology word. I know what it's called when you have those different choices. You haven't heard of it? It's not a continuum. It's a 5-point Likert scale. Okay, a 4-point would be neutral is not allowed, and it's a psychology word. And you've all seen strongly agree, disagree, etc. But that's the name of it. I think named after some person named Likert. All right, so how is this different than what we've done in the last couple of examples? Numbers, nope, that's the same. It's still a qualitative question, right? Strongly agree, disagree, etc. Okay, any thoughts? Okay, in the first one, we had one population. We didn't know its distribution, and we wanted to find out if it fit some special distribution. In the second one, we had one population and we had 2 survey questions that were qualitative, and we wanted to find out if they were independent or dependent. In this one, we have 2 populations, and we have a qualitative survey question, and we want to compare their answers to the qualitative survey question. Do you see how that works? Because we have the population of men and the population of women. And when you have that, the name of the test we're going to use, which I've already talked about, I just didn't do an example yet, is a chi-squared test for homogeneity. Any questions on that? Okay, and when you do that, what we get is an H0 and an H1. You're used to that. So H0 is the distribution of answers to the calculator/computer question. Let me write the distributions of answers are the same for men and women. Any questions on that idea? So notice the word distributions. That's required on this one. H1 is exactly the same, except how is it going to change? One word. We're going to add one word. Yeah, not the same. The distributions of answers. Oops, answers to the calculator. Amazing how many typos I got. Slash computer question are not the same. for men and women. Any questions on this? All right, the good news about this is that the way you do it in the calculator turns out to be exactly the same as chi-squared test for independence. It turns out the math is the same, and that's why the calculator can do it the same. So let me share my desktop and my calculator. And let's go to Matrix. And we're going to go to Edit. We're editing A. Here we have a 2 by 5 table that we had. We have 13, 37, 20, 29, 44. Then we had 29, 51, 55, 30, and 49. Any questions so far? Then we got a stat. Again, this is just the same as what we did with independence. We got a test. We go up. We got a chi-squared test. Observed is A, expected is B. By the way, the expected, the one need for the expected is when you're looking at sample size, you have to make sure all the expected values are greater than 5. Maybe I'll show that in a bit. And then go to calculate. Any questions on that? Okay, our test statistic is about 11.2667, maybe 668, and our p-value is 0.0237. Okay, if the p-value is 0.0237, you should all know what that means. Yeah, statistically significant, not strongly statistically significant, but it's just statistically significant. Because again, the default is 0.05. I want to show you something. If I go back to Matrix, and I go to B this time, and I go to Edit and hit Enter, all of these numbers are bigger than 5. Do you see that? And because they're all bigger than 5, we know our sample size was large enough to do this test satisfactorily. Okay, so now we can type in our answer. And we can say there is statistically significant evidence to conclude. Now I just state H1, that the distributions of answers to the calculated computer question are not the same for men and women. Okay, it looks like not in H1 got cut off. Sorry about that. I don't know what happened. I typed it, but it got cut off on the right-hand side. I wonder if that would work. Nope. Yeah, I'm not sure what happened. Any questions on that? Any questions? Okay, those are the 3 tests. There's the chi-squared test for good as a fit, chi-squared test for independence, and the chi-squared test for homogeneity. They're different. And what's going to be the hardest part? Yeah, you're going to have to pick. And it gets worse than that because on the final exam, I'm just going to give you something and you're going to have to know which it is. And we've already had it could be from chapter 9, it could be from chapter 10, it could be one of these, it could be chapter 11 or it could be chapter 12, it could be chapter 13. Yeah, there's a lot. So you're definitely going to need to practice that. And I'll show you how to practice in a couple weeks. Any questions at all about this example? Any questions? Okay, I have a secret word for you. Again, I promised today would be a little shorter than usual. I always try and make it between an hour and an hour and a half. Every homework question is your question. Yeah, you can, if you ever have a question or a homework question, post it in the Q&A forum, by the way, and I'll answer it. Okay, you need? A secret word. And the secret word for today is qualitative, because this is the week of handling qualitative survey questions. Okay, things like what day of the week were you born on? Okay, it's not a number answer, it's not even yes or no. So that's pretty much everything I have to say for chapter 11. Again, I could give you, there's lots and lots of examples, but at least you got one main example of each of doing it from beginning to end in the calculator. And then the having H0, having H1, being able to name the test, and then write down the conclusion. So any questions? Tammy, Chanel, or Joy? Yeah, my office hours tomorrow, by the way, around 11 o'clock. You're North Lake. That's a long way. Let me show you just in case, especially for you, Joy, because you can't, it's much harder for you to get up here. You're welcome to come to Tahoe, but that's going to be like an hour and a half of driving for you to go to Lake Tahoe Community College. So I'll be here at office hours at 11, but again, it's a lot of driving. Okay. Oh, if there's no way to get here, you definitely can't walk. Especially with the snow. Yeah. But Chanel, again, it's a lot of driving. It's pretty dry, but it's a lot of driving. I want to show you where you can find the way to put it in your calculator. So let me go new share. And that one is, just a minute. That one. It's my email, but it won't be in a second. Let's see, I'm not sure. Let's try it again. Didn't really show. Try one more time. Okay, hopefully you can see it now. So if you go to modules, been a while since I looked at this, but I'm pretty sure it's there. And I put it here, just a minute. It might be in the syllabus. It's been a while since I looked at it. Sorry about that. Oh, I had it, sorry. There's a few places it could be. I apologize. Thought I had it in that module. Let me go to modules one more time. There's one more place it could be. No, it isn't there. No, it's not this one. Let me go find another way. Sorry about that, but I'll show you. Good thing I checked, because it's not there. Let me go my face-to-face. I thought I had it in that one. There it is. It will be on Zoom. Okay, so if you go to modules, it will be there in a minute. Content, full length video, short video, PowerPoint. Let's pop it in. Didn't work. So chi-squared good as a fit. Hopefully this will work. Calculator. All right, now it's in there. Let's hope. It's trying. Yeah, there it is. Okay, so if you go onto your module and you go to week 9 and you click this chi-squared good as a fit calculator program, then that will give you a step-by-step way to program the goodness of fit into your calculator. Sorry, it took a little bit. Any questions on that? And just like slowly watch the video with your calculator in front of you and then type one at a time. Make sure you hit every button they tell you to hit. And then that'll work. Any questions? So again, as always, I'm happy to answer any questions you have, or we can say goodnight, either way. Question of the project. Okay, you can ask the question of the project now. It might help others to hear.
Thank you, Professor. This sounds like this is a really dumb thing, but I've sent a couple of emails to my partners, and we seem to be drawing a total blank on what two things to compare or how to, like nobody has any suggestions. Do you have any ideas on how to stimulate that? I think there's a disconnect on, like I get that you did two different kinds of trees or the left and right side of the stream. I don't know, we're just having a hard time picking something to compare.
I could tell you what some of my other students, what others are doing.
Okay, just to give us some ideas.
But don't do those, you know what I mean?
Yeah, right, yeah.
But it might give you some ideas. So someone from my face-to-face class taught me today, and they want to find out who gets more snow, Heavenly or Kirkwood.
Okay.
And they looked at something like 31 different snowstorms.
Mm-hmm.
And did a paired t-test. I think Chanel, you're doing really it's a common one.
Sure, it's really any two comparable things that as long as there's the data available. So we could look at how many people daily visit Disney World in California versus Disney or Disneyland in California versus Disney World in Florida, or any two things, as long as we can find the data.
For that one, the information has to be available.
Right.
And also a rule is that if you can get all of the data, then it's not okay.
What do you mean by all of
So for example, you couldn't do, on average, who scored more runs, the Red Sox or the Giants last year. Because you could just get all 162 games and do it. And that's not a hypothesis test. You know exactly the number.
Oh, I see. Yes.
You see? So if you could do a census, then it's not okay. It has to be something that you can't get everything of.
Gotcha.
And to try and get every snowstorm that ever happened is pretty impossible. Does that make sense?
Yes. Yes, it does.
And there's lots of other, there's lots and lots of good ones. Sometimes you could do a survey also. Again, it doesn't have to be, going online and getting data. You could do a survey. So, I don't know. Because I used to be a martial arts instructor, and I actually had a martial arts instructor student, and she wanted to see if people can stretch more after doing their workout.
Gotcha.
So she looked at the angle at which you could try to do the splits. Does that make sense?
Yes.
Before the beginning of the workout, and when the workout was over, and saw if there was an increase in that angle.
Okay.
In a martial arts workout, a karate workout. Okay, again,
Right.
I'll give you many, many examples.
Okay, I'll just go back and maybe if I come up with say these are some of the things he shared, and obviously we can't do these, but this should get us thinking. Maybe we can get a little energy behind it. Yeah,
and I forgot, Tammy, where do you live?
I'm in Southern California. I'm in Yucaipa, just down from your good old stomping ground.
That's right, you're Yucaipa. So if it's always more interesting if you could do something that's interesting to you.
Right. Sierra and Jeanette are my partners, and they're both up there. But I lived up there for a few years, and my husband's from Tahoe. We come back all the time, so I'm very familiar with it.
Yeah, so if you have partners from Tahoe, you could do Tahoe stuff. Lake Clarity is a biggie.
Yeah.
That's the big Tahoe thing. There's lots of data on that.
Okay, well, thank you for your advice.
Okay. Any other questions? Chanel, any questions? Joy, any questions? Again, we'll say good night if there's no more questions. But I can answer if you have them. Okay, good night, Tammy. Okay, yeah, and I fixed, all right, we found your error on the spreadsheet thing. But I'll look at the project discussion forum and see if there's any more too. Okay, all right, good night, Chanel. Okay, great. I'll probably get to it tonight after I get home, probably. Okay, have a good night. And for all of you watching this as an archived webinar, have a wonderful week. And don't forget, you should be making good progress on your project. And Chapter 11 is not the hardest one, but it's an important one. So do your best. Post on the Q&A forum if you have questions about it. Post on the project discussion forum if you have questions about the project. And have a wonderful week.